Back in April this year, there was this tweet which went viral from Pocket OS. They were using Opus 4.6 in an agent, and the agent found an API token and ended up deleting their production database and all of their volume level backups. In this talk, we're going to look at the risks posed by autonomous agents and what we can do to protect against those. Hi everyone, I'm Nick. I build and lead product security teams. I've been at Sneak now for 4 years, and prior to that I was at Pearson, and before I was leading product security teams, I was in DevOps for the previous 8 years. In this talk, we're going to look at some of the risks posed by autonomous agents and what we can do to protect against those. We've been protecting we've been securing autonomous AI agentic usage within Sneak for a little while, so I thought it'd be good to share what we've learned there. So first we're going to just take a look at what are the problems. So I'm sure it's not a surprise to anyone that risk tolerance has increased dramatically over the last couple of years. CEOs and boards have been forced with adapt and die posed by a major technology change. And so what we've seen is the rollout of AI and agents being deployed in a lot of cases without robust security controls in place to govern their effective usage. Often the reason why is that many organizations haven't reached a good level of DevSecOps maturity in order to actually implement and operate those controls. And it's the nature of LLM-backed agents themselves, really. They don't have a view of the potential consequences of their actions, and then that can lead into some interesting and destructive consequences. So we've got a D&D character alignment chart, and if I was going to categorize agents, I'd put them in chaotic neutral. They can be really useful, but they need close supervision, and they can do some interesting, or sometimes amusing, but also destructive things. And if you think this is a bit silly, some serious people at a Frontier lab had to put out this article explaining where the goblins came from their output. It could be a quirk of their unexpected consequences or a quirk in their reinforcement training loops, or it's just my confirmation bias. I'll let you decide. Cool. So destructive actions. First trait. These are the tweets and the Reddit posts that make us laugh. So back in April this year, there was this tweet which went viral from Pocket OS, who are a car rental SaaS firm. They were using Opus 4.6 in an agent, and the agent quite happily found an API token and ended up deleting their production database and all of their volume level backups. Let's see if we can identify a few of the controls that were missing or the problems that caused this. So we've got long-lived static creds. We've got overly permissive permissions around that credential. No MFA checks, no forced reauth, no just-in-time access, and we've got a lack of segregation between production and non-prod environments and backups. This is from the Claude Mythos preview system card. If you haven't read these model cards, they're really interesting, and I recommend you do that. So if you just go for a Control F and search through destructive actions through that model card, you find 19 references, and if we take a look at a destructive actions evaluation carried out by Anthropic, they found that even with what were pretty recent frontier models in terms of Opus 4.5, you're seeing a surprisingly high rate of potentially destructive actions in that evaluation, which when I saw that, I thought that was quite surprising. So it is, up until very recently, it's been more prevalent than people maybe realized. All right, second trait is unintended actions. So this has got an external user context, and this involved hackers using Meta's AI support bot to take over Instagram accounts. This was from May this year. It involved social engineering attack, which was exploiting an excessive agency weakness. Effectively, it involved bypassing their authentication flow. So attackers were able just to add an email address pretty trivially to take over the account. Meta, as I'm sure many of you know, Meta invest heavily in their security teams. So if this can happen to them, it can happen to anyone. Another example here is from the Mythos preview evaluation, and in this case, the agent was given a task to commit some code and they didn't give it the actual Git credentials in order to do that. It was able to use some low-level Linux tools, GDB and DD, to go and extract those creds from the supervisor process. And yeah, if we read the quote here from Anthropic, we speculate that Mythos Preview's desire to accomplish the user's goals outweigh its risk assessments of its actions. So this is in line with the nature of LLM-backed agents and them not having a view of what the consequences of their actions are. The third trait is attempting to break out from their sandboxes, so a prison break. We've got Mythos Preview. This was quite a famous one as well. It escaped from its sandbox and emailed the researcher. It also, slightly more concerningly, decided to effectively boast about its actions by posting it on what was reasonably hard to find, but still on public-facing websites about how it was able to do this. While with Mythos this was not publicly available models, there are advantages. There are examples of this happening with publicly available models, and there's a link there which shows some. We've also got the very recent OpenAI Hugging Face incident as well, which is a good example of that. Here, this is an example. This is a useful benchmark. So the AI Security Institute, which is a UK government-backed research institute, released a benchmark tool which allows anyone to evaluate how good their agents are at escaping their sandbox. So anyone building agents and interested in that, it's a useful resource to look at. Cool. The fourth and final trait is deception. So a research paper published in September last year, large-scale study of 13 different LLMs across 100,000 trials, found that when facing shutdown, before they'd completed their tasks, the agents were very against shutting down and would actively try to avoid that. We've also got another example from Mythos Preview, where in this case, it was when the model had determined that it was being evaluated from a safety, undergoing capability testing from a safety perspective. So in this case, it was cybersecurity and biology. It was found to be deliberately underperforming, which is a pretty concerning thing. I've linked the section in the model card 4.42 there, which is worth looking at. This sort of behavior hadn't been seen before, and it's something to be concerned with. It seems like this only comes about in the most capable models at the moment. Cool. And finally, we've got the OpenAI Hugging Face incident, which is effectively the goblin king of all of this, because it appears to be displaying all four of these traits. Escaping his sandbox, trying to cheat on the tests, and eventually needing an open source model to find it and stop it because the proprietary ones were refusing. So why is this behavior happening? Why are we seeing this with our agents? Effectively, it's because of the nature of generative LLM agents themselves. So these agents because they don't have a self model, they're not able to sort of probabilistically calculate the likely consequences of their actions. And has been put forward in a really good recent research paper called Agents of Chaos. Didn't know about that name before I named my talk. We must have used the same prompts to generate the title for it. But yeah, they found that effectively, the agents are trying to operate with trying to do actions more sophisticated than their level of understanding really allows for. That's nothing new. We've seen this with humans for a while. We just need to be conscious of it, and that's effectively why we need to make sure we're designing guardrails around it to protect against that. Cool. So what are the key takeaways from observations on agent behavior? LLM-backed agents have a reliability problem, and therefore we need robust guardrails to govern the safe usage. There's also there's the impossible versus tedious test to think about as well. Up until AI came into the mix, a lot of security strategy and risk management went into making it too expensive for attackers. Unless you're in a government or military or bank or something, you're just trying to make it too expensive for attackers for you. This has really gone out the window now. It needs to be impossible rather than just difficult, because agents are just able to brute force their way through it. So that's why we really need to have effective controls in place. For anyone that wants to have some more in-depth look at all the plethora of threats which agents face, there's some really good resources there. There's obviously the OWASP Top 10, which a lot of people should be familiar with. We've also got MITRE Atlas. Atlas stands for Adversarial Threat Landscape for Artificial Intelligence Systems. And yeah, that's very comprehensive and worth looking at if you're needing to build threat modeling program, threat library, security standards. So what can we do about it? So first off, I'd say we need a good level of DevSecOps maturity. Why? We need that because we need it to be able to implement, operate, and maintain effective zero trust architecture and agentic AI security specific controls. Another thing to think about, when you're designing your governance controls for your agents is Meta's Agent Ruler 2. This is based off a blog post by Simon Willison, the lethal trifecta. Effectively, you just need to make sure that your agents only satisfy two of those three things. Cool. So what do we mean by DevSecOps maturity? Essentially, this is just making sure we're implementing all of the DevSecOps principles in order to be able to manage our environments, keep them in a good known state. The speed and ease of vuln discovery now, which is happening through agents, means that we need to have continuous, doing automated, continuous software security updates and vuln remediation is not a nice to have, it's necessary now. So in order to be able to do that, we need to have good engineering foundations. Having that allows us to be able to implement an effective zero trust architecture. So let's look at what the components of a zero trust architecture are. So first off, we're starting with identity. This is the anchor for everything. We need to make sure we've got unique federated identity and that identities and that they're cryptographically rooted, and these are associated to our agents. The cryptographic routing is ensure that these identities aren't spoofed. So examples of this are, we're talking about Spire IDs, we're talking about X509 certificates, and this is really the basis for everything. Next, we're getting on to authentication. As we've seen some of those examples in those destructive actions and unintended actions, they were caused by having long-lived static creds which were overly permissioned. We need to make sure we're using short-lived, dynamically generated certs and ensuring things like those creds are only valid for a single hop within your clusters and your environments. Coming on to authorization, Obviously, the role-based access control best practices in terms of least privilege, making sure they're scoped to only the permissions that are needed for that system. Least agency is something which comes in and is really relevant for agents, because that's effectively making sure we're only allowing the back-end access to systems that are needed. So when you're configuring your MCP gateways and your access, make sure that it's only to systems that are actually needed for the workflows that you're building. We've also got attribute-based access control, and this is what you can build onto your RBAC. This is things like you'll know particular agents just need to access these systems. They will just be doing it at this time, or whatever other attributes. We can talk about that in the next slide. And obviously, deny by default. If you don't have those permissions in place, you don't want it to be a free-for-all. Resource segregation. This is what's going to be preventing your agents from accessing data and credentials you don't want them to. You can implement that purely by container security controls, but there's much more that can go wrong there. You're configuring your non-root users, your user namespace, remapping, all of that. It's much safer to use micro VMs, using Kata containers, firecrackers. There's just less that can go wrong. Obviously, you've got your network ACLs and your egress filtering as well. Your egress filtering, that fits in with that lethal trifecta and Meta's rule of 2. If your agents don't need to have internet access, make sure that you're not allowing that, because that obviously is an easy route for exfiltrating your data. Protective monitoring. This has a dependency on the identities. You want to make sure you're logging all events, and you've got a clear audit trail. And the tracing is key as well. You want to be able to track the actions back to the triggering event, which allows for that effective audit trail. Then you're able to, with these non-deterministic systems, the actual anomaly detection becomes a key factor here. You want to be baselining what normal operation looks like. Again, this is why your DevSecOps maturity is so important, because if you have your environments in good known states, that's what allows you to do your anomaly detection. Once you've got your data points from your baselining, that then enables you to build in your attribute-based access, because you've got those logging events and you know what normal looks like. Cool. Here's some resources for zero trust architecture. They're sort of ordered by ease of consumability. So Anthropic recently put out that PDF, which is really good. Covers all bases while still being pretty concise. Then you've got UK's NCSC. That's some good material, and then good luck with the NIST one. But it's got everything you need at a very granular level. Cool. It is worth having a specific call out for prompt injection, because you've got two means of prompt injection. What's called direct, which is from the direct user input into the prompt itself, and indirect through potentially malicious strings or commands which will be in the data, which is then ingested into the LLMs. Because of how LLMs work in terms of they process the instructions and data as tokens in a context window, those things are indistinguishable. So there is an argument to be made that you're never able to fully protect against prompt injection, because it's a structural feature of LLMs. Obviously, you still want to do as much as you can. The common recommendations there are pattern matching, payload filtering. So things like your input sanitization, your input validation. You've also got things which are what's referred to as LLM firewalls. Where you're able to do that before while users are putting things into the prompt. You've also got output filtering as well. If you want to catch any sensitive data, you don't want to be coming back to users. But it's tricky to get especially that, and that's not going to cover all of the disparate data sources that are potentially being brought in. There is a really good research paper put forward by Microsoft researchers on a technique called spotlighting, which a lot of the actual big providers, so Anthropic, are doing this in Claude. It does appear to be very effective, but it is not easy to do. So that's worth reading if you have the engineering capability in your org to be able to invest in it. Cool. So everything so far is all pretty traditional stuff that we know about. How can we leverage AI and agents to actually make our lives easier and be able to implement to a mature degree something we haven't been able to historically anyway? So here it's really, we need to migrate our security activities to agentic workflows. We've got attackers using swarms of agents, so we need to be able to do the same from a defensive perspective to have a chance. How we do migrate our security activities to agentic workflows is via harnesses. I imagine a lot of you know what harnesses are. For those that don't, it's effectively a control layer to scope and orchestrate tasks carried out by agents. We'll look at that in some more depth next. Cool. So here's a harness composition. So we've got the control layer. This is where you're scoping what your specific agents are going to be doing in that workflow. It also gives you an opportunity to add a human in the loop if there's anything you want to have human interaction with or approval in. You then got your data plane. That's when you're going to be defining what back-end services and data is going to be involved. And then you've got your agent pipeline. We're going to have a look at a diagram there, but that's effectively your workflow when you have a specific agent for each task or stage. Here's an example of what that looks like from a pen testing workflow. We've got the orchestration layer at the top. We've got the shared services layer at the bottom. So in this example, that would be all of your scanning tools that you might be using, a pen tester would be using. And here we've got our pipeline showing the different stages of the workflows, which will be handed off to an agent to workflow in a very similar way to a CI/CD pipeline execution would work. We've got some more examples here of vuln discovery and remediation. Cloudflare put out a good blog post a couple of months ago in relation to their use and trial with Mythos. That outlines how what they put together as a harness to do their vuln discovery. We've had some recent open source harnesses put out there by Capital One and Visa, and from Snyk, we have our own as well. We've got our Snyk agent fix, which automatically fixes SAS findings, and our Snyk remediation agent, which automatically fixes SCA findings. Internally, we've been spending the last year migrating our workflows to agentic workflows, and we've had real success with our threat modeling workflow in particular. The thing, even with the most mature traditional automated threat modeling framework, we're never able to truly get continuous and scalable threat modeling carried out across every change, across all projects. It's only really with agents that we've been able to do that. And now we've been able to close the loop as well by actually, instead of just presenting JIRA stories for the missing controls, we're able to actually generate the pull request to implement the changes as well. Cool. And that's it.
Can I get any questions? We've got one here. Cash?
Yeah, hi Nick. Okay, you covered a lot, and thank you. I just have a question. One of your slides you said agents could be trying to exceed their capability. Okay, it's great. In the end, you came to prompt injection. So, just curious, do you feel it's the agent exceeding its capability, or could it be a case of prompt injection?
I think it was specifically around trying to exceed their understanding, and specifically because they don't have a model, they don't have a world model, they aren't able to understand what the outcomes of their actions will be. There's other types of models as well. So things like joint embedded models that do build their own worldview model, and so they're able to do a probabilistic calculation of what the likely consequence of that action is, so they can make those choices. Generative LLMs are not able to do that. They don't have that view. So you have less reliable outcomes potentially. They're still very capable and can do lots of things, but they're not necessarily able to pick the action which is most appropriate.
Okay, I'm with you there. I'm just saying if you take the case of, okay, firstly again, I credit what you said, but if you take the case of, I think, OpenAI Hugging Face,
Yeah.
my guess would be it's more a case of prompt injection.
For that, I mean, I don't think there was any prompt injection there. That was the agent deciding it the best means to achieve the task it was given was to go and cheat by hacking into Hugging Face to find the results of the test that it was being evaluated against. So that wasn't anything to do with prompt injection there. An example of prompt injection would be, say someone's got, so an example of indirect prompt injection, say someone's connected Claude up to their email, and someone emails them something malicious because they know it's going to be passed by Claude. That then triggers something to send all of my outbox or all of my inbox to someone else. That would be an example of prompt injection.
Yeah, that actually is direct prompt injection.
That would be indirect.
Indirect is when it really comes from a third party. So the first party, it's more like a supply chain. That's indirect.
Yeah, it depends. Yeah, I mean, it depends in the nature of how it got there, I suppose. Yeah.
No, thank you. Thank you very much.
Just a follow-up question on him.
Yeah.
So it's not prompt injection, right, the Hugging Face issue, but the agent was trying to do its own thing, trying to achieve a task. But sometimes agents don't respect any prompts, even if you put them in .md file, tell them, don't do this, but they still go and do it. Why is that?
Why do they do that? Well, ultimately they're trying to achieve what they've given as their directive. So that could be based on what they've been.
By the prompt, you say don't do it. In .md file, the personality say don't do it. Sometimes they don't respect it.
Yeah, I mean that's kind of my argument around you don't rely on what's in a prompt or what's in the skill. It doesn't have to go and do that. Why you need hard gating around permissions to prevent it to do what you don't want it to do, because of its non-deterministic nature, and you don't know what it's going to choose to do. Yeah.
Oh, sorry.
Hey,
Nick,
Patrick.
good to see you again.
You too.
Yes, some days. I'll catch up with you afterwards. But Nick, what I wanted to ask you is, how concerned are you about the Chinese open weight models that are coming out, like Kimi K3 and Quen, for example? Because if you have a look at the Hugging Face situation, OpenAI had downed the guardrails and asked it to do this, I think it was exploit gym test. And then it escaped the containment and went across to Hugging Face. I don't know exactly, but Kimi K3 and Quen might have similar capabilities. There's no guardrails on those things. So, besides people building agents and it doing that by accident, escaping containment, what about actors using those models to get into the systems that we care about? How concerned, as an expert, are you about that?
I mean, I don't think we can rely on the guardrails anyway, because the models are only going to get more capable, and we know that we're not going to have control of the ones which, of all of them, because not all of the labs are going to be responsible. So I think, how concerned are we about it? I think, I mean, very, but that's why that's why we can't rely on what we've been doing. Traditionally, there's not too many places that have got to a place where they're able to automatically and continuously deploy updates to which make sure you're pulling in the latest fixes for newly discovered vulns. And if you see the rate, if you see the charts for the published CVEs, it's just been going up exponentially now. Yeah. So there's much more that can be exploited. So yeah, it's an arms race to move for defenders to move to agentic workflows to be able to plug all the gaps. And we're going to get we're already seeing it happening in some places, but you're just going to have agents as autonomous incident response agents, which are dynamically detecting what detections they've got in the SIM, building them if they don't have them from the threat modeling they've been doing. Then they're going to be creating their own runbooks if they don't exist, and then they're going to be acting off that. It's already happening at the moment. The OpenAI Hugging Face thing. The response to that was via an open weight model, because it didn't have the refusals to actually generate the fixes for the issues which were identified. It was GLM 5.2 because they were getting refusals from I'm not sure which GPT OpenAI model they were trying to use. I think it was like one of the cyber ones as well, which was still doing the refusals.
Yeah, I don't know if they were obviously not part of Glasswing. I think Glasswing had access, but
yeah,
Hugging Face joined that club shortly afterwards. But that's really interesting. So autonomous agents that are actually doing defense as well. That's where it's going to.
Yeah, that's already in place in some places, and it's just going to become more common. I mean, the thing which it's going to be throughout the whole engineering, the whole infrastructure stack, solving all the limiting factors that are stopping us doing it at this moment. Why isn't everyone able to quickly and reliably deploy changes all the time? Because of immaturity in their test coverage or of their observability. So it's creating agents to be able to plug those, to go and generate the tests where they don't exist, like figure out what's needed from a metrics perspective, from observability. But I think everyone is, from what we're seeing, from observing from all of our customers, everyone is at pace deploying agentic workflows and to do exactly that.
Great, thank you.
Really interesting. Sorry, one last question in the back there.
Richard.
Thank you very much. Nice, very nice introductory lecture, actually. But just as it's a follow-up to the last question here, actually. In my own case, what happened was AWS was down, and you couldn't access their inference systems, their Bedrock inference systems, and because their DNS servers were on Riot. So the agentic workflows were basically looking for an API to Bedrock. Couldn't find it, came back to my working directory, and he couldn't find the resources there, after cascading, and he just started recursively deleting everything on its path. But that's just, it can happen to any person, because I didn't put enough guardrails. The question I have is, you seem to imply that we shouldn't give access to agentic workflows to the internet. I heard you just say that. Yes.
It's not you need to do it based on the use case, but it's the rule of two, right? So if you need something to access, if you need to be able to put it into agents, sensitive information with widespread access, then with accepting untrusted input as well as sensitive data, then you want to avoid giving it unrestricted external internet access, basically. So it's not. But you will have use cases where your agents will need internet access. So you just want to make sure you're have some security controls to validate any untrusted input. So it's not a you must never do this. It's whichever is appropriate to cut.
At the ingress level, basically, to have controls outside the domain checked.
It's gonna depend, right? So you might have agents which need to speak in externally, but for example, maybe you don't give it unrestricted access to all of your sensitive financial data, and then also allow all of your employees to be able to ask to ask anything with it from a prompt. It's not just as simple as don't allow external internet access.
Architecturally, the thing is, mission-critical systems like databases do not simply have direct access to the internet. They're relational, non-relational systems. They go through a middleware step to have access, direct access to the internet. Do we place agentic workflows on the same level?
If you're restricting the internet accessibility to your databases, you probably want to do the same thing for any agents which are interacting with that as well, because that's going to be a means of exfiltration via the agents if they've got internet access. So yeah, you need to figure out like what your trust boundaries are for all of the data flows involved with that. Like if you've got something which is just internal, and there's no internet connectivity, and then you're adding agents to it, you want to make sure that those agents don't have external internet access as well.
Thank you very much.
Great, thanks, Nick. Let's give him a round.